Hi, my name is Stuart Lynch. In this video, we're turning our demo app into a fully functional Swift package. I'm going to guide you through organization of the files for our SFSymbolPicker. We'll expose the right components, and then we'll publish the package to GitHub and update the README so others can start using your SFSymbolPicker too. Now that we have our demo app created, we can create a Swift package by separating out the content that we need to use for our package. Now I have a complete video on this topic that you may wish to watch where I go into more detail. Link is in the description. But let me take you through the process for this particular SFSymbolPicker package. I suggest that you want to organize your project and files so that maintaining your package will be easier in the long run. So let's create a new folder somewhere in your file system and call it SFSymbolPicker Master. And then move in your demo project, the SFSymbolPicker demo folder, right into that folder. And then open the SFSymbolPicker demo application in Xcode. From here, you can create a Swift package. From the File menu, choose New, and then Package. Choose Multi-Platform and Library, and then click on Next. Now, we're not going to be using a testing system here, so I'm going to leave this as None, and then click on Next. And I'm going to name the package SFSymbolPicker. And make sure that you have a Create Git repository on my Mac checked. I recommend that you save it at the same level as your SFSymbolPicker demo project, not inside your actual demo project. And add that to the SFSymbolPicker demo and make sure that the group is the same. And then create your package. Your project will now have a new link to that package where you'll see a Package.swift Manifest file and a sources folder. We'll need to modify the manifest file, the Package.swift file. And we want this to be available not only for iOS, but for also iPadOS and macOS. And we'll be using the latest versions of those operating systems. So after the name, add a platform argument and specify an array of platforms along with the minimum version supported. So for me, that is iOS version 18 and macOS version 15. And also make sure you add a comma to separate the arguments for the package. Then in the target section, after the name, but before the closing parenthesis, add a comma and then add a resources argument. And it's here that we need to specify what resources our packages need, and that's our array ofplists. So we'll need to use the process rule to process the resources. And since they're going to be at the root level of our package, we can just specify each name as a string. So I'm going to carefully type in these 4 plists, checking to make sure that I don't make any spelling errors. The order doesn't matter. Now we need to move the files from our project into the sources folder of our package. Inside the packages sources folder, you'll see the SFSymbolPicker folder, where we need to move all of our files from our app's SFSymbol source folder. And if you expand that folder now, you'll see a placeholder file, and you can simply just delete that. Now you can drag the entire contents of the SFSymbol source folder into the sources SFSymbolPicker folder. And when you do this, it copies the files over, but leaves the other ones behind as well. And we'll no longer be needing those files in the project itself. So delete the old SFSymbol source folder, and your project should look like what you see here. You're not done yet though. You'll need to make sure that your demo app can see that package, as it is now a framework and it's a different module. So select your app target, then go to the Frameworks, Libraries, and Embedded Content section. Tap the plus button, and you should see your package available at the top. So select the package and click on Add. Let's return to our real project's content view right now. And you'll see that it can't find the symbol loader class in this because we've moved those files out and moved them into our framework. So we'll need to import the SFSymbolPicker package. Now you're still getting errors because the framework package files and resources are private and available only to the framework itself. So we'll need to expose all the necessary components to our demo app by making those parts public. And our content view needs to access the symbol loader class itself. So we'll return to the symbol loader in our package and make the symbol loader class public. Now this will also require that we make the initializer public as well. Now there's no need to expose any of the three functions here as public functions, as the build SFSymbols array function is only accessed by the class, as is the decode plist function. The available categories function is not used by our content view either, but it is used by the symbol view. But the symbol view itself is a member of the framework, so that's fine. However, we do need to expose the SFSymbol view struct to our demo app. So we're going to go to that file and make the SFSymbol view public. There are still errors when we try to build though. So like the symbol loader struct, we'll also need to make the initializer public as well. But this adds more problems. The initializer is using the symbol loader function, which is public, but it also needs access to the category enum, which is not. So we'll need to return to the models file and locate the category enum and make sure that this enum is public. And then back in the symbol view, there is still one more error, and that's the body property, which needs to be made public as well. Your project should now compile without errors, but in the content view, your preview isn't loading. If you check the preview's diagnostics, you'll see that we're getting fatal errors when it's trying to locate the categories plist. And this is because our decode plist function is still looking in bundle.main, and we've moved our files into a module. So we can solve this problem simply by, in the symbol loader class and the decode plist function, change the bundle.main to bundle.module. Now, when we return to content view, we can see that our view is now being presented, and we can access each one of those symbols to initiate a SymbolPicker view. I hope you're enjoying this video, and if you are, please give it a thumbs up and leave me a comment. It would also really help if you could subscribe to my channel and enable notifications so that you're alerted when I drop a new one here on YouTube. I put out weekly videos and I seldom miss a week, so if you really want to support my work, you can buy me a coffee. A link is in the description. There's still more work to do though. We said that we want our app to be able to be used on macOS. So in our demo app, let's add a new target for macOS. So we're going to select macOS as the target. And I'm going to call this Mac_SFSymbolPicker. And once it's created, we get our new target. So if we want to use this SFSymbol package in this target, we'll need to make sure that it's loaded. So go to the project menu and select the Mac target. As we did for the iOS app in the Frameworks library and Embedded Content section, we need to add the framework. I can return now to our content view, and I can now import SFSymbolPicker. If we build now, we'll find that we still have some errors. In the SFSymbol view, we'll see those are where the errors are, and that's because the Mac doesn't understand auto capitalization or text field style. Those are iOS modifiers only. And in fact, we don't even need these for the Mac. So what we can do is we can make these conditional by using a compiler if OS is iOS and surround that with an end if. And the second error is here because the background is using a UI color and there is no NS color equivalent, which is what the Mac uses. So we could use another conditional. If the OS is iOS, we can use what we have. But then we can use an else with an end if, and then just copy and paste what we used for iOS and change the fill color to a quaternary label color when we're on the Mac. Your project will now build for iOS and macOS. So let's make sure that everything is working. We'll select the content view of the Mac app, and then I'm going to create a state property for an SF symbol, and I'm going to give it the default string of globe. And then I'll replace the string for the SF symbol in the body with that state property. I'm going to create another state property called change image and initialize it as false. We'll use that to trigger our picker. But I'll also need a state property to initialize the symbol loader class so that we can present that with our picker, with the decoded content. Then I can apply an on-tap gesture to the image. And within the body, we'll simply just toggle that change image Boolean property. And you can remove the text view if you like. And now we can attach a sheet to the VStack that is presented as bound to that change image state property. And then we can present any one of the symbol view versions that we like. So I'm going to present the symbol view with the loader and the selected symbol and some limited categories. So loader is loader. The selected symbol is the symbol. And for the limited categories, I'm just going to choose two of them. And I'm going to choose automotive and transportation. Now you can't present a sheet for macOS in the preview. So I'm going to need to run this on my Mac. We can see now that I have that symbol in the middle of this window. And when I tap on it, I get that picker. And I can update and change my symbol. Now, before we decide to make our package public, we really should add a README file. Now, the README file gets added at the same level as the Package.swift file. So create a new file and then search for Markdown and select it. And this will automatically create a Markdown file for you named readme.md with a header title that you can change. So let's give it the name of our package, SFSymbolPicker. And it's below here that you're going to want to provide instructions for consumers of this package on how to implement it. And I'll get to that in a few minutes. So let's make this package available to others. And in order to do that, we'll need to make sure that our package is under source control. So exit out of the demo app and then locate the SFSymbolPicker folder. And we can launch it by double-clicking on the Package.swift file. When I created the package, I did have the Create Git repository on my Mac checkbox enabled, so my files are under source control but not yet committed. Now, if you didn't have them under source control, you can do that by choosing the Integrate New Git repository, and that'll stage and commit all files to your local repository. Since I had that checkbox enabled, though, I still need to commit. So from the Integrate menu, choose Commit, and then Stage All, and then add a comment, something like version 1.0, and commit your files. Now, you don't have to add this package to GitHub. You can actually add it as a local package in your projects. And since this is located in your master folder, you should be able to find it so long as you don't move it. But this might be dangerous, so I always recommend that you keep it on GitHub where the package gets downloaded and added to your project, rather than just a reference to some file and folder in a fixed location. So I'm going to go right to the GitHub stage right away here. To make it available in GitHub, Either privately or publicly, you'll need to have a GitHub account. And I cover this in my series on source control with GitHub, and you can find it specifically in this one video. Once you have the account and your package is under source control, you can go to the Source Control Navigator and the Repositories tab. And you can see that we have a single main branch. Right-click on Remote and then choose New SFSymbolPicker Remote. And you can make it either public or private. I'm just going to make mine private for now, but I can make it public later on. Next, click on the branch and give it a new tag by right-clicking on it and choosing Tag Main. And here's where you specify the tag version. So I'm going to specify 1.0. And then from here, from the Integrate menu, choose Push, but also make sure you check the Include Tags checkbox, as this will let the consumers know which version this is. Then if you reveal the Remote section, you can see that we have an origin now. And if you right-click on origin, you can view on GitHub from here. And this will open up your GitHub repository. So copy the URL, as this is what you'll need to add the package to a new project. So let's do that. Let's create a new test project. And I'm just going to call it Test Project, and it'll be an iOS app. And I'm just going to save it to my master folder. You can save it wherever you like. Now you can add your package. So from the File menu, choose Add Package Dependency. And then paste the URL into the search field and your package will appear. Notice that now the package will accept up to the next major version from 1.0. So click on Add Package and then Add Package again. And you will see that package dependency has been added with the 1.0.0 tag, and that's displayed here. And if I tap on the README file, I see that it's that rather bare bones README file that we created. As I said, we'll get into that. Now in our content view, we can use this package so long as we import SFSymbolPicker. So let's repeat the same process that we did for the Mac target here in this new test project. We'll import SFSymbolPicker, but there's no need to add it as a framework. We can skip that step because adding it as a Swift package does that for us. Now we'll add a state property for the symbol and initialize it as the string globe. We'll create another state property called change image and initialize it as false. That's going to allow us to present the sheet. And then create an instance of the loader, the symbol loader class as loader. And then you can replace the string in the image view with that variable symbol. Next, we'll add an on tap gesture to the image. And within here, we'll toggle the change image boolean. And I can remove the text view. Now we can present the sheet based on the isPresented binding to the change image boolean. And that's going to allow us to present some view, and that can be our symbol view. And I'm just going to present the one with all of the categories. So no limited categories or search terms. The loader will be our loader, and the selected symbol will be our symbol. So as you can see now, we have our picker working from a Swift package. Now what about that README? Well, if you're going to be making your package available to others, you should probably do two things. You should document your code using docc, but that's beyond the scope of this tutorial. That might be for another video sometime. But at the very least, your README on GitHub should contain information about the package and how to implement it. And right now it just contains the package title. Now I've taken the liberty of editing that README file, and I'm going to replace that one that we have here. And if I open the SFSymbolPicker package now and look at the README, you can see that it's all here done in Markdown. And I use my trusty app Typora to create this for me, and you can see that it is a very visual editor. I have a full video on this tool, and the link is in the description, but there are other Markdown tools that will allow you to visually create Markdown. So now that it's been updated, I want to push this up to GitHub so that it refreshes the page, and whenever people install or update the package, they'll get that update. So first, let me commit those changes. But before I push it up to GitHub though, whenever we want to update a package, we must add a new tag. And I cover all of this in my video that I referred to at the very beginning of this tutorial about Swift Package Manager. Now you may wish to, for example, expose more of your models or functions in your project or add different views. And if that's the case, you'll need to add the content, expose the models and functions with public designation, and make sure that you have a new tag when you push the repository back to GitHub. In our case, all we did was update the README file, but still we'll need to tag it and push it up to GitHub. So first, let's just make sure that we stage and commit our changes before we tag and push it up. Now, right now on the main branch, we added that single tag, which was 1.0. So if we right click and add a new tag, we can call it 1.1. So as we push this change, we'll need to make sure that we include the tags. And now I can go back to the project that I had already installed, and we can see that it's still at 1.0. So what we can do is we can right click on the package and choose Update Package. And it will fetch that new version because it has a newer, more recent tag. And you can now see that the version number has increased. And if I reveal the Markdown file, we can see what it looks like in raw Markdown. If I open the GitHub repo, I can see now that the consumers of this project will now know how to install and implement the package. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember I have a full SwiftUI course available on my Teachable site where you learn how to build a fun multi-targeted app.